Hello everyone and welcome back. My name is Mr. Kovold, and in this video I'm going to be going over how to determine the empirical formula of a substance. I'm going to begin with starting by defining empirical formula versus molecular formulas. So let's get into this. So what is an empirical formula? An empirical formula is a chemical formula where the subscripts represent the simplest whole number ratio of the atoms in the compound. So, for example, H2O would be the empirical formula of water because it gives me a 2-to-1 ratio, and I can't get any simpler than that. So that would be the empirical formula for water, right? What is a molecular formula? The molecular formula is the formula where the subscripts give you the actual numbers of each atom in the compound. So if I use water again as an example, right? So here, again, H2O would be the molecular formula for water because in reality, the water molecule has two hydrogens and one oxygen. So the subscripts represent the actual numbers of the atoms that are in the molecule of water. So every water molecule actually has two hydrogens and one oxygen. It just so happens that the empirical formula is the same because this is the lowest whole number ratio that you can get. Now, we can use a different examples. So if we take H2O2, that's hydrogen peroxide. So this is the molecular formula of hydrogen peroxide. So every hydrogen peroxide molecule has two hydrogens and two oxygens in the molecule, right? So this is what these are the actual numbers of the atoms of hydrogen and oxygen in a molecule of hydrogen peroxide. But this is not the lowest whole number ratio for this molecule. So you can notice that we have a 2 and a 2. We can reduce or simplify that to 1-to-1. So if we reduce that or simplify it, the formula would be like that. Now, this here is the empirical formula for hydrogen peroxide, as you can see here. So this is the molecular formula with the subscripts representing the actual number of atoms in the molecule, whereas this is the empirical formula, and this is only representing the smallest whole number ratio of the atoms in the formula. So 1-to-1 is the smallest ratio. So this is the molecular formula with the actual number of atoms in the molecule. This is the empirical formula for hydrogen peroxide that gives the lowest whole number ratio. Okay, what's another example? Another example would be C6H12O6. So this is the molecular formula for glucose, sugar. So a glucose molecule actually has 6 carbons, 12 hydrogens, and 6 oxygens in a molecule of glucose. So this is the molecular formula, but you could see that 6, 12, and 6 is not the simplest whole number ratio you can get. So 6 is half of 12, 12 is double that of 6. So we can simplify this by writing CH2O. So this is the empirical formula for glucose. So you can see here that 1 to 2-to-1 is the simplest whole number ratio of 6, 12, and 6. So this is the molecular formula, which gives us the actual number of carbon and hydrogen, oxygen atoms in the molecule, whereas CH2O gives us the simplest whole number ratio. So this is the empirical formula of glucose. This is the molecular formula of glucose. So that is how we distinguish empirical formula from molecular formula. So how do we determine the empirical formula that we have when we're given information about the elements in the compound? Well, this is how you do it. If you are given the percent composition of each element, right? Like, so if you're given it's 12% carbon, 32% oxygen, 25% nitrogen or whatever, what you need to do is change those percentages to grams. And the way you do that is because a percentage means out of 100, right? 12% means that 12 out of 100, right? 25% means 25 out of 100. Well, if that's the case, just assume that you have 100 grams of your substance. If 12% of 100 grams is carbon, then that means out of 100 grams, you have 12 grams of carbon. So the 12% becomes 12 grams, right? So if you just assume 100 grams of your substance, then the percentages all convert to grams. So if you have 12%, change it to 12 grams. If you have 25% of hydrogen, change that to 12 grams of hydrogen, or I'm sorry, 25 grams of hydrogen. So whatever the percentage of the element you have, that becomes grams because you're assuming 100 grams of your substance. Okay, now you get to grams here. Now, if they give you grams right away, if they say you have this many grams of carbon and this many grams of hydrogen and so on, you can use those grams as they are. So if they give you grams, then you're going to start here. If they give you a percentage, then you're going to convert that to grams by assuming 100 grams of your compound, and then all the percentages become grams anyway. Okay, so if you've got grams of each element in a specific amount of the compound, then what you need to do is convert that to moles of the element. So if I have 12 grams, if I'm told out of 50 grams of my substance, 12 grams is carbon and 13 grams is oxygen and the rest is nitrogen, then I can convert each of those grams to moles using the molar mass of each element, right? So I know that carbon, the molar mass of carbon is 12.011 grams for every mole. Well, if I have, say, 25 grams of carbon in my compound, then I can use that 25 grams, I can use the molar mass, convert 25 grams to moles. And I can do that for each element that I have the mass for. So convert grams to moles using the molar masses of your elements. And then once you got the moles of each element, now you can use those moles to create a mole ratio. And then once you got the mole ratio, you've got your empirical formula. So I know this is maybe a little bit cryptic, but I'll show that with an example. So stay tuned. Okay, so here's my example. So I have a sample of phosphor and it's analyzed and found to have 12.368 grams of calcium and 6.358 grams of phosphorus. What's the empirical formula for this phosphor? Okay, so in this case, I'm not given percentages of calcium and phosphorus. I'm given the grams. So I can just start with the grams that they give me, and then my first step is to convert to moles. Because remember, the empirical formula is the formula where the subscripts are the simplest whole number ratio, right? And those are molar ratios, as I've shown in my previous video. The subscripts are molar ratios. So I need to convert grams to moles and compare those to get a molar ratio. So the first step when you're given grams is to just convert that to moles using the molar mass of each element. So I'm going to take the 12.368 8 grams, and this is calcium, and I'm going to use the molar mass to convert that to moles. And what's the molar mass of calcium? 40.078. So I'm going to put 40.0, what did I say? 078 grams of calcium on the bottom and 1 mole of calcium on top. So grams cancel out. So now I have moles. And so when I calculate that out, I get 0.30860. So 0.30860 moles of calcium. And then I do the same thing with phosphorus. So I'm going to take the phosphorus, 6.358 grams of phosphorus. And I'm going to use the molar mass of phosphorus to convert that to grams. And the molar mass is 30.9738. So 30.9738 grams of phosphorus. Let me just double check that. 9738, yes. So that goes on the bottom, and 1 mole of phosphorus goes on top. So grams of phosphorus cancel out. And when I calculate this, I get 0.2053. 0.2053 moles of phosphorus. Okay, so that's the first step. So I've converted grams to moles. Now that I have moles, I can figure out what the mole ratio is between these. Now, the way you want to figure out the mole ratio is to take the smallest mole amount that you have from the elements and divide them all by that amount. The reason for this is because you want to get a ratio of 1 to some number either equal to 1 or larger than 1. So you're going to take the smallest one and divide everything by that smallest one. So between these mole amounts that I have for these elements, I have 0.2053 and I have 0.30860. So the smallest of these two is this one here. This is the smaller one. So I'm going to divide both of these by the smaller one. So when I do that, I'm going to divide this one by 0.2053 moles. I'm going to divide this one by 0.2053 moles. And of course, when I divide this by itself, that gives me a 1. And when I divide that, that gives me, let me double check, 1.503. So this is going to be 1.503. So if I divide both of these by the smallest one, I get a 1 to 1.5. So this is basically pretty much 1.5. So I get a 1 to 1.5 ratio. So what I can do at this point is I can set up my formula like so, or yeah, let me set up my formula. So then what I can do is I can set up the formula. So this will be the mole ratio. So I have 1 mole of phosphorus for every 1.5 moles of calcium. So when I write this down, remember the metal always is written first in the formula. So it's going to be 1.5 as a subscript. So remember, the mole ratios are the subscripts. The subscripts give the mole ratio. So what I found here is the subscripts. So then I have calcium 1.5 and then I have P, and there's a 1. Now, normally you don't write 1s, but for the sake of this problem, we're going to put 1 down. Okay, now that's our mole ratio. However, our subscripts don't have fractions. You can't have a fractional subscript. So what we need to do is get rid of the fraction. But we don't want to change the ratio. The ratio is 1 to 1.5. So we need to multiply everything by the same factor. So how do you get rid of a half? Multiply by 2. So if I multiply this by 2, then I can get rid of the half. But if I multiply this by 2, then I multiply this by 2 as well. So everything gets multiplied by 2. So 1.5 multiplied by 2 is 3. So this becomes Ca3. And 1 times 2 is 2. So that becomes subscript 2. So then, ladies and gentlemen, that is the smallest whole number ratio that we can get, and therefore we have the empirical formula. Okay, so that's the empirical formula. So again, let's walk through the steps again. The goal is to get to the smallest whole number ratio. If we're given grams, we're given grams of calcium and grams of phosphorus. First step, take the grams, use the molar mass of each element to convert to moles. So here we have moles of calcium, moles of phosphorus. That's step 1. The next step is to get a mole ratio of 1 to something. And we're going to do that by dividing all of the moles that we got by the smallest mole amount of whichever element that has that smallest amount. In this case, this phosphorus had the smallest mole amount, the smaller mole amount. So we're going to divide both of them by 0.2053. So of course, when you divide a number by itself, you get 1. And then here, when we divided this mole amount by this mole amount, we got 1.503, which is very, very close to 1.5, so you can round that to 1.5. Then since we got this ratio of 1 to 1.5, we put those numbers in as subscripts for the elements. And then last but not least, we get rid of the fraction by multiplying by the factor to get rid of that fraction. And this is true for any fraction. So if you get 1.333, well, 333 is 1/3. So then you would have to multiply by 3 to get rid of the fraction. If you got 0.25, then you would have to multiply by 1/4, or you would have to multiply by 4 to get rid of the 1/4, right? And so on. So anytime you get a fraction that's an obvious, clear fraction, then multiply by that factor. But then again, you got to multiply everything. All of the subscripts have to be multiplied. Okay. Now, there's a slightly different way that you could have done this. So one way, but it's exactly the same steps. Let me erase this and kind of start over here. So at this point, what I could have done is created what is called a pseudo formula, right? A pseudo formula is going to be a formula for the substance, but it's not reduced yet. So here, remember what I said about the subscripts in a formula. The subscripts represent your mole ratio, the mole amounts of each element in 1 mole of the compound. So those are your moles. What do we have here? We just converted each element to moles, so we could actually put these in as subscripts. So then what we can do is write a pseudo formula using these mole amounts as subscripts. So then I write my pseudo formula, so Ca, and then I write this down as a subscript, 0.30860. So there's my subscript, and then I write this as a subscript. So P and the subscript is 0.2053. So here's my pseudo formula for the substance. So there is a ratio here, but it's not very simplified. So we're going to simplify this. So again, you do the exact same thing. How do you simplify? The first thing you're going to do is take the smallest number and divide all of the numbers by the smallest number. So again, this is the smallest number. So I'm going to divide this one by 0.2053. And then this one I'm going to divide by 0.2053. And again, I get the CA 1.5 and then P1. And then again, I'm going to get rid of the fraction by multiplying by 2, but I multiply all of the subscripts by 2. So I'm going to multiply 1.5 by 2. That gives me 3 subscript for calcium, and 1 times 2 is 2. That gives me phosphorus 2. So I get the same formula. So basically the same steps. So that's how you can determine the empirical formula from the substance as well as the molecular formula. But the molecular formula I will do in my next video. Oops, excuse me. Sorry about that. As I was saying, I will do the molecular formula, how you find the molecular formula in my next video. So I hope this is helpful as far as knowing the difference between a molecular formula and empirical formula, and how you can determine the empirical formula from the given information that you're given. Either you're given mass amounts of the elements, like you're given here, or you're given the percent amounts. In which case, if you're given percent amounts, you want to convert the percentages to grams. It's going to be the exact same number, except instead of 12%, it's going to be 12 grams. 25% becomes 25 grams because we're assuming 100 grams of the compound. So that's it for this video. If you enjoyed the video, if you liked the video, please share the video with your friends. Hit that like button. Subscribe to my channel. Hit that notification bell. When you do, make sure that you click all, so that way when you can get notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, put that down below. If you have a particular problem or question you want me to help you with, put that down below. I would be happy to do that for you. Thanks for joining me, and have a great day.